Okay, here we are looking at Vioxx, and it says that the study revealed that it was associated with an increase in the risk of heart attack. The experiment was placebo-controlled, randomized, and double-blind. Out of 1,287 people taking Vioxx, there were 45 heart attacks, and out of 1,299 people taking the placebo, there were 25 heart attacks. Okay, so we've got 1287 taking Vioxx, and we had 45 heart attacks. And then we have 1,299 people taking placebo, and we had 25 heart attacks. It says perform a hypothesis test to test whether those who take Vioxx have a greater rate of heart attacks than those who take a placebo. And it says use a significance level of 0.05. Okay, and we want to know, do Vioxx users have a greater risk of heart attack? Okay, and then we choose our conclusion at the very end. Okay, so first off, we want to just make sure, does it even make sense that to ask this question, does Vioxx increase the risk of heart attack? Okay, so the percentage. So let's find the percentage for those who had Vioxx. Okay, so I'm going to write p hat for Vioxx. This is the sample proportion for Vioxx users. The people who had heart attacks, there were 45 divided by 1287. And when I calculate this out, I get 0.0349. So actually I'm going to just round off to 0.035. So 3.5% of Vioxx users had heart attacks. Okay, I'm going to just write HA for heart attack. And then, I'll write heart attack. And then for the placebo users, okay, we had 25 people out of 1299 had heart attacks. So I do 25 divided by 1299, and I get 0.0192. So that's like 1.9%. So I'll just round off to 1.9% of placebo users had heart attacks. Okay, so sure, it makes sense. The sample, in our sample, okay, Vioxx users had a greater percentage or higher proportion of heart attacks. And the question is, so we see a higher proportion in our sample, but is this indicative of a higher proportion in the population? So our null hypothesis is that no, the difference that we see is just by random chance, and that the proportion of people of Vioxx users that have heart attacks is the same as the proportion of placebo users who have heart attacks. The alternative is that, and it asks, does Vioxx increase the risk of heart attack? So we're asking, does the proportion with those who take Vioxx, is that higher than the proportion of placebo users who get heart attacks? Okay, so that's our alternative hypothesis. Okay, now when we check conditions, we're not sampling random, but we have random assignment. So random assignment for the experiment works. So random assignment. Okay, and we can check n times p hat for both groups. So, and when we do this, we get for 1,287, or actually not times p hat. So the overall proportion that we observed, our p hat, okay, so we have to figure out our p hat. The overall proportion, this is the number, total number of heart attacks divided by total people. Okay, so we had a total of 45 people in the Vioxx group and 25 people in the placebo group who had heart attacks, divided by 1287 plus 1299 people total. So on top, this gives me 70, and 1287, plus 1299 gives me 2586. So 70 divided by 2586, this gives me 0.027. Alright, so I can check n times p hat and n times 1 minus p hat for all of these, and they all for the Vioxx group. Okay, so I check 1287 times 0.027, that's going to be bigger than 10. I check 1287 times 1 minus 0.027, that's also bigger than 10. 1299 times 0.027 is bigger than 10, and 1299 times 1 minus 0.027 is bigger than 10. So my large sample is met. And do we have a big population? So is it reasonable to think that there's more than, that our population is more than 10 times this, and our population is more than 10 times this? Yeah, because there's a lot of people out there, so we can do that. Okay, so now we have to figure out our test statistic. Our test statistic is what we observed, our observed difference, minus the hypothesized difference in our null hypothesis, divided by our standard error. Okay, so I'm going to just erase some space here. Okay, so my standard error is I'm going to use the p hat that we've used, calculated there. So my standard error is going to be the square root of 0.027 times 1 minus 0.027 times 1 over n1, which is 1287, plus 1 over n2, which is 1299. And so when I do the calculations, I'm going to do the inner part first. 1 over 1287 plus 1 over 1299. I multiply that by 0.027 times 1 minus 0.027 in parentheses, and I take the square root of that. And this gives me 0.00637. Okay, and the observed difference, so my observed difference is 3.5% minus 1.9%, so 0.035, so you don't use percentages but change to decimals, minus 0.019, that's my observed difference. The hypothesis says my difference should be 0, and I'm going to divide by my standard error, which is 0.00637. Okay, and I get a z-score of 2.51. Okay, that's my my z-score. Now, if you round it off or kept more decimals or have fewer decimals, you might have something a little bit off. But if it's around 2.4, 2.5, you should be in good shape. Okay, and so now we want to find the p-value, the area in the tail that's beyond 2.51. Okay, So now our alternative hypothesis indicates this is a one-tail test. So I'm only going to look up the area beyond one side. So if I look up 2.51, I have 0.994 on this side, which means the amount over here I have 0.006. That's the total area in that side of the tail, 0.006. 0.0060. Okay, so that's my p-value. So let me just give me a little bit of space up here. Alright, so my p-value is 0.0060. Okay, so that's very small. That is less than my alpha, which is 0.05. So I reject the null hypothesis. Okay, and I conclude that I have evidence that Vioxx users have a higher risk of heart attack. Okay, which means that the difference that we observed in our sample, the 3.5% versus 1.9%, that was a significant difference. Okay, the difference in our sample was significant. And that's that.